This is Mission Control Houston, Discovery Commander Eileen Collins controlling the vehicle as it pitches up. This in a maneuver that provides photography of the external tank from a distance much closer than any previous missions. Photography maneuver of this type has been done on past shuttle flights. This maneuver, however, will result in photography of the tank from a distance of about 1,500 feet between it and the shuttle, versus previous maneuvers done somewhat a few minutes later after jettison of the tank, which resulted in photography at a distance of about 4,400 feet between the shuttle and the tank. That closer distance allows for what is hoped to be much better resolution in the imagery that's being taken by the crew and transmitted down to the ground for analysis of design changes made to the tank for the shuttle's return to flight. On board Discovery, Soichi Noguchi is taking video through the overhead windows of the tank. Andy Thomas is using an electronic camera to take still photography of the tank as it falls away. They'll only have about a minute or two total of time to photograph the tank once it's centered in the windows. This is an animation that shows the maneuver being done by Discovery Commander Eileen Collins and by the crew then to photograph the tank from the overhead windows of the shuttle. This showing the view they have, again a distance expected to be about 1,500 feet between the tank and Discovery as it's being photographed, with video on board by Soichi Noguchi and with still imagery, electronic imagery sent to the ground by Andy Thomas. That imagery won't be sent to the ground, however, until day 3 of the mission. They have only a couple of minutes to photograph the tank as it begins to fall away. Coming up for Discovery also in about 24 minutes will be a orbital maneuvering system engine firing. That's the firing of the 2 engines on either side of the tail of the spacecraft. It will raise the current low point of Discovery's orbit. The Discovery's currently traveling 17,600 miles per hour, but on a ballistic trajectory, where if it did not fire its engines, it would re-enter the Earth's atmosphere on the other side of the Earth. Its current apogee and perigee, high point and low point of its current orbit, is 137 statute miles for the high point, 36 statute miles for the low point. In about 23.5 minutes, when Discovery has coasted out toward the high point of its current orbit, it will fire.
Discovery Houston, for Vegas, you have a go for the hide MPS TVC ISOL valve steps and the APU hide shutdown steps in sequence as written.
That'll work, thanks.
In about 23 minutes from now, Discovery will fire its 2 orbital maneuvering system engines to raise its low point of its current orbit to 98 statute miles. That will have it in an orbit that will be 140 statute miles by 98 statute miles. It will remain in that orbit for about 5 hours until just before the crew's sleep period begins this afternoon, somewhere around 3 p.m. Central Time this afternoon, when another engine firing will further increase its orbital altitude, raising it to 191 statute miles by 141 statute miles. The orbital changes slowly bring Discovery's orbit up to that of the International Space Station, the station at about 220 statute miles altitude, as Discovery begins an orbital rendezvous with the station that will occur over the next 2 days, slowly catching up on the station and raising its orbit as it does to decrease the rate at which it closes in on the complex. During Discovery's ascent to orbit, very quiet in mission control, with no problems seen by flight controllers, no concerns voiced to Ascent Flight Director Leroy Kane. just down the hall from the shuttle flight control room here at Mission Control Houston in the International Space Station flight control room. Word was given to the station crew as they actually were able to watch a live uplink of Discovery's launch this morning on board the station, sent to them from the station flight control room. Then resulting in congratulations at the conclusion of Discovery's ascent sent down to the ground and to the team by Commander Sergei Krikalev aboard the station and astronaut NASA science officer John Phillips. The two station crew members are currently in the midst of a 6-month stay on board the orbiting research complex. Discovery is now at an altitude of 98 statute miles above the North Atlantic Ocean.
We'll meet you on the other side on pages 3-4 and 3-5.
And Discovery copies. Thank you.
That call a normal reconfiguring of Discovery's onboard communications system to prepare it for orbital communications. Coming up, we'll replay views from cameras taken of Discovery's launch from the Kennedy Space Center. We'll be switching to the Kennedy Space Center for those replays, but continuing with live audio from Mission Control and air-to-ground between Discovery and the Control Center as those replays progress.
And Discovery Houston, we're back with you for pages 3-4 and 5.
Discovery's ready to copy.
Okay, Eileen, tail-only control is not required. We'll take the remainder of the steps on 3-4 in sequence. You'll be go for Ops 105 when you get there. Regarding the OMS 2 burn, you will be 2 engines, straight feed, burning the onboard targets. Your TIG will be 38:00. How copy?
Houston, Discovery copies. Tail only control is not required. We'll do page 3-4 in sequence with the go for Ops 105 when we get there. On the OMS 2, 2 engines straight feed, onboard targets 38:00.
Good copy on all.
This is Mission Control Houston. We're watching replays from cameras that recorded views of Discovery's launch this morning. Discovery in flight now for 20 minutes as it crosses Great Britain at an altitude of 111 statute miles. In about 17.5 minutes, Discovery's 2 orbital maneuvering system engines on either side of the tail of the spacecraft will fire. That to raise Discovery's orbit slightly, raising it into an orbit with a low point of 98 statute miles and a high point of 140 statute miles. The first step in Discovery's rendezvous with the International Space Station.
page 3-4?
Go ahead.
The ET photo is still in progress, so we'd like to hold off on the A12 steps for now and proceed down through Ops 105 if you concur with that. And that's just for a spacing issue.
And Eileen, that's no problem at all. You can execute those steps as you desire, and we'll watch for you and bring you back with a reminder if you need it. And while I got you, would like you to check left flight control power to off, DAP to auto, and for Vegas, APU controller power is all 3 to off.
Okay, Houston, where ET photo is still in progress, but I'll go ahead and turn off the flight controller power and go to auto at this time, and Vegas is checking his controllers.
Great, thanks.
Houston Discovery, if you like the targets, we'll go ahead and load them on page 3-5.
And Eileen, we'll take a TIG of 38:00, and you have a go to load.
Okay, we were wondering about that. We'll go ahead and update it, and then we'll load.
Thank you.
This is Mission Control Houston as we continue to watch replays of views from the Kennedy Space Center, recorded of Discovery's launch. Discovery at present is at an altitude of 127 statute miles above northern Italy. On board and in Mission Control.
Agility output 3-6 in work as written.
And Vegas, you have a go for page 3-6.
on board Discovery and here in Mission Control. Clocks are counting down toward an orbital maneuvering system engine firing. That's firing by both engines on either side of the tail of Discovery. They'll fire for about 1 minute and 5 seconds. That starts at about 10:17 a.m. Central Time. The result will increase Discovery speed by about 68 miles per hour, but boost the low point of Discovery's current orbit. That low point is currently about 36 statute miles. It will raise that low point up to about 98 statute miles and essentially be the first burn in the series that over the next 2 days will culminate in a docking of Discovery to the International Space Station, all on track for that docking, which is anticipated at about 6:18 a.m. Central Time on Thursday. Once this upcoming engine firing is completed, some other milestones for the crew as they set up shop for an extended stay in orbit aboard Discovery will be transitioning flight control computers on board to the software that's used for orbital operations, and also opening the payload bay doors of the spacecraft to provide cooling for the cooling systems on board. The radiators along the interior of the payload bay doors are the primary mechanism for cooling the spacecraft in orbit.
ETM Boca door closure.
And Vegas, you're go for the doors.
Inward.
That call to pilot Jim Kelly that he can begin throwing switches that will close the external tank doors, doors that cover locations where the external tank and umbilicals connect on the underside of the vehicle. All of that going normally. As Discovery continues toward an engine firing that will be the first in a series of firings to rendezvous with the International Space Station, about 8 minutes away from that engine firing by both orbital maneuvering system engines. They'll be fired for about 1 minute and 5 seconds. Discovery's altitude currently 136 statute miles, as it is above the eastern Mediterranean Sea.
Discovery ETM Boca door closure complete.
We concur, thanks.
Houston, we're ready to start the maneuver to the on-phone attitude if you concur.
We concur, Eileen. You are go to maneuver.
Those calls from Discovery, first pilot Jim Kelly confirming that the external tank umbilical well doors are closed and latched now. All of that going very smoothly, as watched over by the Mechanical Systems Officer in Mission Control as well, and also Commander Eileen Collins given a go to begin maneuvering Discovery into the proper orientation for this engine firing, now about just over 6 minutes away. 1 minute 5 second long firing of both orbital maneuvering system engines aboard Discovery. That firing will increase the speed of Discovery by only about 68 miles per hour, but raise the low point of Discovery's current orbit from about 36 statute miles to 98 statute miles. Once this burn is complete, Discovery will be in an orbit of 140 statute miles by 98 statute miles. It'll remain in that orbit for several hours until just before 3 p.m. Central Time this afternoon, when another engine firing will be performed, to further raise Discovery's orbit to about 191 statute miles by 141 statute miles. That's the orbit that Discovery will be in while the crew sleeps for their first night in orbit. We'll continue to watch replays of launch from the Kennedy Space Center in Florida. This is a view from the external tank camera during Discovery's climb to orbit.
Houston Discovery, the A12 step sound work. And after that's complete, we are up to the middle of page 3-8.
Okay, we copy, and we are about 45 seconds to hand over to Z.
Copy that, and just to let you know, we still see the ET out the front window with the sun shining on it.
That must look neat.
It looks beautiful, and the sun's going down about now.
That call from Commander Eileen Collins that the crew still has a visual of the external fuel tank as it descends away from Discovery. Discovery and the tank both moving into nightfall now. The sun will rise and set for Discovery every 45 minutes as it circles the Earth. Discovery just about to move off the coast of Saudi Arabia above the Indian Ocean. Discovery's altitude now about 142 statute miles as it moves out above the Indian Ocean. 2.5 minutes away from an orbital maneuvering system engine firing. 1 minute 5 second long firing of the two engines on the other side of the tail of Discovery that will raise its current orbit, raising the low point, putting it in an orbit of about 140 statute miles by 98 statute miles when this engine firing is completed.
Discovery Houston, we're back with you on Z and see you in a good config for OMS 2.
Discovery copies.
just under 30 seconds away now from an engine firing by Discovery's 2 orbital maneuvering system engines. They'll fire for 1 minute 5 seconds, raising the low point of Discovery's orbit from 36 statute miles to an altitude of about 98 statute miles. Discovery over the nighttime Indian Ocean. Propulsion officer reports the 2 orbital maneuvering system engines are firing, all looking good. Again, about a minute 5 second long firing for those engines.
Discovery Houston, we saw a good ohms 2 burn, no trim required.
Discovery agrees.
Call confirming that Discovery's orbital maneuvering system engine firing complete. Discovery now in an orbit with a high point of 142 statute miles, a low point of 98 statute miles, closing in toward the International Space Station. It'll continue in this orbit, playing basically orbital catch-up toward the International Space Station for the next several hours. Another engine firing is planned at around 3 p.m. Central Time this afternoon, to further increase the altitude of Discovery's orbit.
Discovery Houston for pages 5-2 and 5-3, white pages, post-ohms 2.
And Houston, we're there. We're up to the gimbal check if you're ready.
Eileen, we are ready for the gimbal check. Furthermore, we're ready for all actions in sequence. You'll be go for UPS 106. And while I have you, could you give us a window report?
Yes, sir. Copy all of page 5-2 and 5-3. We'll work it. We're in the dark right now, but the windows actually looked pretty good. I just had about 3 or 4 small streaks at the base of window number 3 and about 1 on window number 2. And I'll let the pilot give you his report here in a minute.
Hey, Houston from the PLT, window 4 looked pretty clean. Window 5 had 3 or 4 smudges. Window 6 looked fine.
Great, we copy all. That sounds great.
And Houston, here comes the gimbal check.
We're watching.
The next engine firing for Discovery again about 3 p.m. Central Time this afternoon. That will further increase the altitude of Discovery's orbit. That upcoming firing would put Discovery in an orbit with a high point of 191 statute miles, a low point of 141 statute miles. Discovery's current orbit has a high point of 140 statute miles, a low point of 98 statute miles. As the altitude of Discovery's orbit is slowly raised by engine firings over the next couple of days, it has the net effect of slowing the rate at which Discovery is closing in on the International Space Station, leading to the docking with the station, planned on Thursday at about 6:18 a.m. Central Time.
From the mid-deck, we're working preliminary mid-deck config block 2. CS switches.
Houston Discovery from the mid-deck, putting blocks 5 and 6 in work.
We copy.
Houston Discovery with an update.
Go ahead, Eileen.
We have completed the actions in the ascent checklist. We're done with page 5-3 with just a few cleanups. We're going to move to post-insertion at this time. And we'll be switching our helmet comm over to speaker mic, and we'll give you a comm check on that shortly.
I have one small comment on block 1, and when you get on the headsets, let me know.
Okay, and we'll give you a call.
Aboard Discovery, the crew now beginning to exit their seats as they begin the work of setting up Discovery for an extended stay in orbit and its trip to the International Space Station. On the flight deck during Discovery's climb to orbit, along with Commander Eileen Collins and pilot Jim Kelly, was mission specialist Soichi Noguchi and flight engineer Steve Robinson. On the lower deck of Discovery during its climb to orbit were astronauts Andy Thomas, Wendy Lawrence, and Charlie Camarda. They'll all begin exiting seats now and donning the orange launch and entry suits, or doffing the orange launch and entry suits worn during the climb to orbit. Some major milestones as they approach a go for orbit operations, which is the official signal that they have set up shop and all is in order for an extended stay in orbit, include the opening of the payload bay doors and the activation of radiators located along the interior of those doors that are one of the primary cooling systems for Discovery during its time in orbit. Opening of the payload bay doors is anticipated about 45 minutes from now or so.
Discovery, common check.
Loud and clear, Soichi.
Thank you, loud and clear too.
This graphic from Mission Control shows Discovery's current orientation in space and position over the Earth.
Flight deck.
Copy.
Discovery's altitude now 140 statute miles above the nighttime Indian Ocean. Coming up on NASA television in a few minutes, we anticipate continued replays of Discovery's launch from cameras around the launch site at the Kennedy Space Center. On board Discovery, the crew in a very busy time frame as they move through a variety of procedures to set up shop on board, configuring the crew cabin for operations in orbit. One of the highlights, the opening of the payload bay doors on Discovery. That payload bay door opening comes at about an hour and a half after launch. That's about 40 minutes or so from now. Then about 2 hours or so after launch, the crew completes those initial setup operations on board and will likely receive a go for orbit operations. That's the official go that Discovery is ready for an extended stay in orbit, continuing its mission toward the International Space Station. Again, these replays of engineering views of Discovery's launch from the Kennedy Space Center this morning. All systems on board Discovery are in good shape. Flight controllers here in Mission Control discussing no concerns with the spacecraft. This is Mission Control Houston on NASA television. We're continuing to watch replays of Discovery's launch this morning from the Kennedy Space Center. These varying views of the launch recorded by cameras around the launch site. On board Discovery, the crew continuing to set up shop in orbit. Coming up for them, one of the major milestones is about a half an hour away. That'll be the opening of the payload bay doors. It is possible we may get live television for Discovery of the opening of the doors, as at that time Discovery will be over the Johnson Space Center and a spaceflight tracking system that is available here through which television may be able to be received. Payload bay door opening activities on board are anticipated to take place around 11:06 a.m. Central Time. On board, the crew is taking off the orange launch and entry suits, the partial pressure suits they wore during the climb to orbit, preparing to set up the cabin for orbital operations.
In Houston, Discovery is starting the circuit breaker check on page 1-3.
And we're with you.
As activities smoothly progress aboard Discovery, again as the crew setting up shop in orbit. Coming up on NASA television also at approximately 11 a.m. Central Time, noon Eastern, will be a post-launch press conference from the Kennedy Space Center in Florida. That post-launch press conference anticipated around 11 a.m. Central Time.
And Houston, Discovery is ready for your change on block 1.
Okay, Eileen, it's just a small note. In step 4, you will be dual G2.
Step 4 will be dual G2. Copy.
That's a good copy. And while I have you, Eileen, if you'll flip over to page 1-5 in the timeline, I have a change to the maneuver to payload bay opening attitude.
We're on page 1-5 and ready to copy.
Okay, that will be target ID 2, body vector 5, pitch 9090, yaw 7, and Omicron 266. How copy?
Body vector will be 5, pitch 90, yaw 7, and Omicron 266. And while I have you, we just thought we'd pass on that for the EP photo, both Andy and Soichi got some very, very good photos over a long period of time, so hopefully we'll have some good stuff to send down to you tomorrow.
Okay, that's going to be awesome, and we can pass back to you that the stack camera on the way up was absolutely stunning all the way through ET-SEP.
Oh, that's great to hear. And Houston, Andy would like to pass down our thanks to Dave and Rao for all the ET photo training that they got, and he did make sure that there is film in the camera.
And pass back to him that that is great news. We appreciate it.
Roger that. Houston, we're starting block 1.
Copy, we're watching.
As we continue to watch replays of engineering camera views of Discovery's launch from the Kennedy Space Center, all systems on board Discovery continue to operate well, with Discovery now above the Southern Ocean, south of Australia.
Block 3 is in work.
Thank you.
Last communications between the crew and mission control, Eileen Collins confirming that astronauts Soichi Noguchi and Andy Thomas got very good imagery of the external tank during the external tank maneuver that was performed by Discovery. That maneuver performed at a point where the tank was closer to the shuttle than ever before to allow imagery at a distance almost a third of what previous imagery had been done in that type of maneuver. That imagery will be transmitted to the ground on day 3 of the mission.
If you like the NBAT, we'll do the Ops 106 mode recall.
And we like your NBAT.
This is Mission Control Houston as we continue to watch replays of camera views of Discovery's launch this morning. Coming up on NASA television at around 11 a.m. Central Time will be a post-launch press conference that originating from the Kennedy Space Center. Participants in that press conference are anticipated to be Administrator Mike Griffin, Bill Reedy, the Associate Administrator for the Office of Space Operations, Bill Parsons, Space Shuttle Program Manager, and Mike Leinbach, NASA Launch Director for Discovery's launch. All activities continue to go well on board. Upcoming milestone will be the opening of payload bay doors on Discovery. That's anticipated about 11:06 a.m. Central Time. We may get television down of that opening through ground sites located at the Johnson Space Center here in Houston as the Discovery flies overhead. The KU-band antenna, the dish-shaped antenna that is deployed over the side of the payload bay of Discovery and that allows the majority of television transmission to the ground, will not be deployed and activated until about 3 a.m. Central Time on Wednesday.
Discovery, we're in step 4, and if you like the NVAT, we'll do the Ops 201 transition.
And we like your NVAT. Your go for the transition.
That call from Commander Eileen Collins that the crew's ready to transition the onboard flight control computers for Discovery to the software that's used for orbital operations, package called Ops 201. That as they continue through a very busy pace for the next hour or so of setting up the spacecraft and the cabin for an extended stay in orbit. A data processing systems officer in Mission Control reports she sees the onboard flight control computers transitioning now to the orbit operations software. Software transitions completed on board Discovery. All that going smoothly.
Discovery, Block 3 is complete.
Thanks, Steve.
Houston Discovery starting Block 4.
Copy, thanks.
Houston Discovery Blocks 5 and 6 are complete.
Thanks, Wendy.
And Houston Discovery, we're going to load the DAP at this time and the maneuver.
Okay, we're ready for that.
Houston Discovery, like to put payload bus activation in work.
And we're ready for that, Vegas.
This is Mission Control Houston. We continue to watch replays of recorded views of Discovery's launch. On board, the crew continuing through their activities to set up shop in orbit. Discovery's moved into its first sunrise in space. Sunrise and sunset coming every 45 minutes for the spacecraft, respectively, as it circles the Earth each hour and a half. On board, coming up for the crew is the milestone of opening the payload bay doors, to allow radiators along the interior of the doors to cool shuttle systems. That milestone is Discovery sets up shop in orbit and prepares the cabin and spacecraft systems for extended operations. Coming up on NASA television in just a few minutes will be a post-launch press conference, that originating from the Kennedy Space Center. That anticipated around 11 a.m. Central Time, noon Eastern, in just a few minutes on NASA television. Participants in the post-launch press conference upcoming include NASA Administrator Mike Griffin, Associate Administrator for the Office of Space Operations Bill Reedy, Bill Parsons, the Space Shuttle Program Manager, and Mike Leinbach, NASA Launch Director. Again, that press conference coming up in just a few minutes on NASA television. All activities continue to go well for Discovery and crew as they focus toward the next milestone for them, opening the payload bay doors.
And Houston Discovery with an update, we're up to step 9.
Copy, we're watching.
Good afternoon and welcome to NASA's Kennedy Space Center. I've been waiting 2 years to say this, but welcome to everyone as we have our post-launch press conference. And congratulations to everybody up here and the teams that have worked hard on this for the last 2.5 years. We're going to have some brief remarks from our folks up here, and then we'll go to questions. Again, I'd like you to, as standard procedure, please identify yourself and your affiliate before asking a question. Let me introduce our briefing members today. To my left is Michael Griffin, NASA Administrator. To his left, William Reedy, Associate Administrator for Space Operations. To his left, Bill Parsons, Space Shuttle Program Manager. To his left, Wayne Hale, Deputy Program Manager for the Space Shuttle Program. And to his left, Mike Leinbach, Shuttle Launch Director. As I said, a few brief remarks, and then we'll get to some questions. Mr. Administrator?
Thank you, Dean, and thanks to all of you here. I'll keep my opening remarks brief, but I want to use them to ask you all to take note of what you saw here today. The power and the majesty of the launch, of course, but also the competence and the professionalism, the sheer gall, the pluckiness, the grittiness of this team that pulled this program out of the depths of despair 2.5 years ago and made it fly. I want you to think about what it takes to get millions of different parts from thousands of vendors across the country to work together to produce what you saw here today, to realize how chancy it is, how difficult it is, at what a primitive state of technology it still is. And this team managed to do it, and I think a large debt of appreciation is due to them. They have worked as hard as any team in NASA history to produce what you saw today. Thank you.
Amen. This has been a total team effort since the very beginning, 2.5 years ago, and as all of you have followed along with us, it's been a struggle, a constant struggle to overcome an awful lot of things. What you didn't see out on the launch pad today was the fact that Atlantis is stacked in the VAB ready to go. We've accomplished a tremendous amount, but this is the launch. We've got 12 days of orbit operations to do, and then we've got to get Discovery and her crew safely back home. I think today Mother Nature smiled on us, and I also think the Columbia crew smiled on us. We owe them and their families a debt of gratitude. The entire NASA family does. And to get Eileen and her crew up safely on orbit today with a pristine vehicle and a superb count, I just can't say enough good things about the team that I've been fortunate to be associated with. Bill?
I'd just like to send a personal thanks to all our shuttle program folks, the NASA workers, the contractors, the NASA centers that jumped in and helped us out, solve so many technical problems. You just can't believe what an effort this was for this agency, and I can't tell you how much support this program got in our effort. And I just echo what Bill said. We still got some work to do, and then we'll bring the crew home safely, and we'll fly another one. So I really, again, I just can't tell you what this means today.
I don't know how to begin. My heart's been in my throat all morning. It's been a great day, and to think that here we are today with Americans back in flight on an American vehicle is just a tremendous step, and it'll be the first in many steps as we head out into the exploration of the solar system back to the moon and onto Mars. And his team showed a kind of spirit and dedication to overcome difficulties that is going to take, and I couldn't be more proud of them. It's a great day.
Times like this, I get to represent the launch team and really all of Kennedy Space Center. And I just wish you all could have been in the lobby of the Launch Control Center when we were enjoying our beans and cornbread that we hadn't enjoyed in over 2.5 years. The mood was just giddy. People were just slapping each other on the back. And there won't be one thing better than today's launch, and that'll be the landing in 12 days. All right, that'll be it for our opening remarks. We'll now take questions, and please identify yourself and your affiliate. Let's go right here in the blue shirt, Jay Barbary.
Jay Barbary with NBC. First, let me ask you a question as a journalist. Did you see any debris or anything come off today in your early tapes? And as a non-journalist who has covered all 145 missions, magnificent, okay? Did you see any debris?
Well, let me just say, I talked with the two senior members of the photo imagery group that were on their way to review the imagery. It's a little early to make comments on what's going on. You know, you have to have some experience and some knowledge to be able to interpret the photography. I did get an early report before we left the firing room from the radar team that said they saw no tracks prior to SRB SEP, and of course at SRB SEP we put off booster covers and different things that we know come off. So far, I think the best shot was that shot of the external tank looking back at the orbiter as it flew away, and it looked really good. We'll have to see, though. The guys are going over that frame by frame, and tomorrow, you know, we'll have a better story for you.
All right, along the wall, let's go with Mike Cabbage.
Mike Cabbage with the Orlando Sentinel. To follow up on Jay's question, it appears someone who's not an expert, certainly, from watching the film from the ET camera that right after the solid rocket boosters separate, that there's clearly some kind of a debris event. It doesn't appear to strike the orbiter, but it does look like it's a large piece of debris. Have you gotten any additional information on what that could be, where it could have come from, or what's going on with it?
No. No. We're waiting for the experts to come back and tell us.
All right, next question, right there in front. Blue shirt.
Simon with KHWV, TV in Houston. The sensors work today. What's your reaction to that, and do you feel like you could finally put this to bed as an unexplained anomaly, as you call it?
Is that for me? Or
That's for you, that's fine.
I'm a little disappointed, I'll be very honest with you. Having worked through the rationale and satisfied ourselves right up to including me that we were good to go with 3 of 4, I said the other day, and I meant it, I wanted the one that failed the other day to fail again, because we had some diagnostic procedures in place today, and maybe we could have removed the U from the UA and turned it into an EA, and that would have been nice to do. So now we're in the position that I think Mike Leinbach said earlier, we have an unexplained resolution. and I guess that's good, but engineers don't like the unexplained, and now the evidence is, or at least half the evidence is gone, never to be seen again.
All right, let's stay back along the wall. Tracy.
Tracy watching USA Today, I guess for Mr. Hale. Were you relieved to see by the end of the countdown that the sensors were all working right?
It's always good to have a clean vehicle where everything's working right. So yes, I was very pleased. I kind of thought that might happen. So
I'll tell you, we had a very detailed troubleshooting plan that we ran through today, and try as we might, we were not able to make an eco sensor fail today. So it was a good feeling.
Worked hard at it, huh?
Yeah, that's right.
Second row, blue shirt. Tom.
Thank you very much. Tom Costello from NBC News. Was there anything at all today that didn't go as picture perfect as it appeared to have gone to all of us watching, and both on the ground and also on television? Was there anything, any glitches, anything that didn't go right?
I talked to Mission Control just a couple minutes before I came over here, and there is one temperature sensor that has become erratic.
What does that mean?
Not much. Not much. One out of hundreds.
And I'll tell you, from the launch countdown perspective, it was a very, very clean countdown. We had some liquid nitrogen dripping out of the ground umbilical carrier plate, which connects to the external tank, the hydrogen vent arm at the end of the hydrogen vent arm. But we've seen that before, and really that was the biggest thing we talked about. We were waiting for the ecos to rear their heads, and they never did. So from my perspective, it was a very, very clean countdown.
Right up front, right here in black.
Stefano Coledan for Time Magazine. Mr. Weinbach, you literally picked up the pieces of Columbia, put them together. You were also launch director for that launch, and today you are probably experiencing the high of having launched another shuttle safely. Can you just give us tell us how you feel? I mean, all of these highs and lows.
It's been a ride for the whole shuttle program. I saw a close friend of one of the Columbia crew that was lost after launch. I saw her down in the lobby, and we embraced, and it was a very special moment. She helped me in the hangar when we were putting the debris together. So for her especially, it was very important. But really for the whole team, we've come almost full circle. We have a 12-day mission ahead of us and a landing, and then we can claim we've come full circle.
Second row, green shirt. Ralph.
Ralph Artabedian, Los Angeles Times. Now that you've got a successful launch, do you feel that there is any lasting damage in terms of the public support or your confidence in the Columbia accident, or as you say, have you come full circle and now you're firing again on all 8 cylinders and it's all history?
I think that it was a misnomer that public support ever flagged during the downtime. Matter of fact, immediately after the accident, I think people recognized that we're in a very risky business and it's very important. During the downtime, we even had the solicitation for the educator astronauts. That was at an all-time high. I think we've got 19 billion websites. That was earlier this week and probably after the launch today. It shows that there's always been a tremendous amount of public support, and I think the vision for space exploration has helped ignite that. This is the first step on the way to doing that, the return to flight, getting the station built, moving on beyond low Earth orbit and getting them back to the moon and onto Mars. I think people endorse that, people around the world. It's one of the nobler things that we do on behalf of all mankind, and people appreciate that. So I disagree with your initial premise. I think the support's always been there. It's probably higher today than it's been in some time. You know, you're never as good as you are until your next launch. You know, that's the operations business that we're in. You're always working on that next launch, and you can never let down your guard. And I think that was one of the lessons relearned after Columbia, is it takes eternal vigilance to do what we do. And there isn't anything easy about it. And I'll guarantee you, knowing the people that are lined up here on the dais with me and the people they represent around the NASA family, there isn't anything easy about this on any given day. And the fact that Discovery was so clean today is a tribute to all the folks that worked since August of 2001 to put that vehicle back together piece by piece by piece. And it was pristine today when we went to go launch, and I think Eileen and her crew have got the best vehicle we've ever fielded, and Atlantis is going to be equally good when it goes flying in September.
Front row right here in the white shirt.
Mike Schneider, Associated Press. I know you all are related about the pristine launch, but I was wondering if the celebration has been muted compared to past launches because of the uncertainty about the next 12 days?
Well, surely. I mean, the first thing you learn as a student pilot is that the flight's not over until the engine is shut off and the airplane's tied down. And we have, as Mike Leinbach said, 12 more days plus before we achieve that state. And that's when we'll know that this was a safe flight.
You know, I'd have to add, this is a difficult mission. We still have a lot of complex maneuvers to do. We still have a lot of test objectives to meet. And we still have a lot out in front of us. And this team, although we were very proud and very elated to see the launch today and see how well the countdown went and everything else, there's still a lot of work in front of us. And so this team will come together after this, and they'll get head down and start coloring again, because there's still a lot of work to do.
Yeah, I think Wayne will probably vouch for the fact that this is a very, very ambitious mission, and it was so ambitious that during return to flight we decided to separate it into 2 flight tests. So we've got a tremendous amount of work ahead of us, and it's a very complex mission. I think the crew is probably the best trained crew we've ever flown, even including Captain John Young and Bob Crippen. I think Eileen and her crew have been in training for this mission since 2001. So this is the best trained crew that we've probably ever had, but it's also probably one of the most complex test missions we've ever attempted. And this is just the first half.
Okay, let's go right here in the front row. John.
John Kelly with Florida Today. Wayne, what's the MMT schedule, if you could help us out here? Are you guys going to get any kind of film analysis tonight, or will you not start meeting until tomorrow? And what's your first steps here?
Most of the film team is going to be reviewing those films for the next 12 hours or so. We'll get, as an MMT, a quick look tomorrow morning early, and then our regular schedule of MMT meetings will be 1 in the afternoon Central Time. for the duration of the flight. And I think we have promised to come talk to you folks almost every day, if not every day, to tell you what we know. And we'll be here to let you know on a daily basis.
Let's go end of the row, white shirt.
Hi, Benno Schmidt, High Definition News. I'm wondering if you, with the luxury of hindsight and what appears as a successful launch, if you can talk a little bit again, and this is for Wayne, about how the decision was made to go ahead and launch with an unexplained anomaly and what that might mean to Atlantis and other shuttles, and also, you know, how hard it was to replicate launch conditions in a lab.
Well, of course, there are a couple of things that you can't replicate until you get into a launch countdown, one of which is the thermal environment. You've got to load the cryogenics in the tank to get everything chilled down to those temperatures, which certainly can affect electronics or the wiring. The other thing that's very difficult to emulate is some of the potential electromagnetic interferences, and until you get all the equipment on and all the power up in the ship, you know, we did what we thought were the big potential contributors to that, but until you have everything on all at once and you're getting the full power draw through the system, you don't know how it's going to affect it. So really we had to get into this launch countdown configuration to really do the final test, if you want to call it, of how these sensors were going to work. I would say that the decision that led up to proceeding to launch with less than full up set of sensors was extremely thorough. It was not taken lightly, was very heavily studied, heavily debated, lots of technical analysis and input went into it. It was not a snap decision. It was well reasoned, and I think that was a good plan. I'm glad we didn't have to execute it, and I will tell you that after we'll stop on Discovery, we'll think about what it means to Atlantis and the subsequent flights, but probably not before then. We have plenty to do to keep us busy until we get the Discovery crew back home safe.
Third row, pink shirt, guy.
Guy Gugliotta for the Washington Post. For Wayne, does that mean that you won't make a decision on whether to fly with 3 for Atlantis until this mission is done, or has that decision already been made?
No, I'll repeat. We're probably not going to talk anything more about eco-sensors until after the flight's over, and then we'll think about the next flight and where it goes. The folks that would be involved in that kind of discussion are heavily involved in the mission activities, and we need to stay focused on that up front.
All right, right here in the third row, green shirt.
Thank you. Greg Dobbs from HDNet. As scientifically as your minds tend to work, would each of you mind telling us just briefly how you felt emotionally during those first 60 seconds?
I don't know. I was watching displays and camera footage, looking for evidence of what we were all looking for, anything coming off the tank. Just trying to evaluate what we were seeing from an engineering perspective, realizing, of course, that it wasn't ever going to be as good as all the post-game replays that we will do. But if you want honesty, I've got to be honest with you. I was engaged in what was going on and was not aware of what I might or might not be feeling. I'm sorry.
Somebody had to do it.
Everyone was doing it.
None of you was just taking even a moment to pump your fist and say, go, baby, go.
Oh, I'm sure. We were all. there was more emotion in the Launch Control Center than I've seen in all the times that I've been in there for launches. There were people clapping at various stages. There was some emotion in that firing room. So I would just say we were all feeling it, but every time it was just that moment, and then we moved on to again concentrate on what was going on with the launch and trying to see as much as we could and hear as much as we could and understand what was going on. I had Bill sitting next to me, so he was giving me kind of a blow-by-blow of what the crew was feeling, and there's nothing like hearing it from somebody that's done it before. So, you know, Mike, your guys were they were pretty up.
We were pretty pumped. But our job in the control center is not over until we don't have a return to launch site aboard. which is about 4.5 minutes into the flight. And so when the launch team kind of did a little cheer at SRB separation, I'm going to have to go back and talk to them about that. Because the rules are we don't do that. But nevertheless, it was a human reaction that you could not quell. And then, of course, at MECO and at separation, when we saw the separation for the first time live, was just surreal almost.
All right, right here, second row, white shirt.
Randy Avera, Randolph Publishing. First part for Wayne Hale. Do you have a plan to do any special launch commit criteria reviews prior to the next flight? And for Dr. Griffin, could you tell us a little bit about your strategies for possibly accelerating the return to the moon? Have you thought about that in detail?
Let me answer first. Today is about discovery and about the first of our return to flight missions, and that's all it's about. And I just don't have any comments about anything beyond that. Other topics are going to be for other times.
So the Launch Commit Working Group meets every Monday at 10 a.m. And they will meet every Monday, and they'll talk about all the different things that they talk about, and I'm sure that there may be one or two related meetings about eco-sensors, but again, that'll be after we get Discovery back on the ground.
Third row, blue shirt.
Thank you. Jeff Patterson with WFLA TV out of Tampa, and this is a question for Mr. Hale. I know you said that there would be a frame-by-frame review of the various camera angles that you have, but have you had a chance to review some of them just from an aesthetic point of view? I mean, the freeze frame that you have behind you is beautiful. It almost looks like science fiction, and this has offered a unique perspective, I suppose, not only this angle, but the aircraft that we're flying around. Have you had a chance to look at some of those shots, and what is your assessment just from an aesthetic point of view?
Just from what we saw during the launch, we were watching out the window, the great, beautiful, wonderful launch where the rocket seems to just take off right over the Launch Control Center. And then as it went out of sight, turned around and looked at the television and saw this magnificent view of the Earth and the orbiter from the external tank camera, and particularly when it rolled heads up, it just brought a gasp out from everybody because it was just astounding footage that we'd never seen before. And it's aesthetically wonderful.
And from a crew member standpoint, it's really nice to be able to share some of that. I mean, that's what you see, that's what you experience, and for the team to be able to see that up close and personal this time, I think it was magnificent. I was kind of kidding Pat Youngs, who's Eileen's husband, about the fact that Eileen was doing a victory roll on her way to orbit. She just couldn't contain herself. That's kind of how we were feeling about that same time, I think.
All right, a few more questions. Against the wall over there, let's go with Mark. Second.
Thank you, Mark Carreau from the Houston Chronicle. I wondered if you could talk about the external tank from the vantage point of the ice inspection team, if what they saw was what you expected, that kind of condition. And could you tell us a little bit about the camera coverage you got today? Not so much the results, but did you have the numbers of cameras working that you needed to do the evaluation you plan over the next several days?
Well, let's see, the inspection of the external tank by the final inspection team. It's the tank, it's the boosters, it's the orbiter, and it's the ground systems also. And it was almost a flawless report. The first time we attempted a launch 10 days or so ago, there was an ice ball that had formed. We expected that ice ball to form again today. It was smaller today than we had anticipated, and it was smaller than it was 10 days or so ago. The vehicle was in great shape. It was wet. Water was dripping off of it. Condensation formed. It was a very humid day. But these are all things we've seen many, many times before. And so Armando Oliu, the head of the final inspection team, did his thing and reported virtually a flawless vehicle back to the control center. And we were go at that point from that perspective.
All right, a few more right. Stay back along the wall, maroon shirt.
Thank you. Tarek Malik from Space.com and Space News. I was just curious as to when in this mission, knowing that you have to have some time to process your ground observations, your orbital photography, and the photography from the space station, as well as the sensors along the inside of the wing, when will you have a comprehensive understanding of what the status of this vehicle is after this launch and docking at the space station?
We've laid out a very comprehensive timeline to get all of that back in. As you know, we have, in addition to the video cameras, some of which are regular old-fashioned kind of television cameras and then high-definition television cameras, we have a large number of film cameras that give us very high resolution. That film's got to be sent out and developed. We're going to have film also from the WB-57s, which I'm told tracked all the way from launch through main engine cutoff. So those will be some views that we've never seen before. That'll be about another day before it comes in. We've got cameras also in the solid rocket boosters that those will have to be towed back into Port Canaveral before we can access that videotape and see what's on those cameras. In terms of the sensors in the wing leading edge, that data will be downlinked tonight during the crew sleep period from mission control. And all of this information, plus the radars, plus the other instrumentation, the boom sensor survey they're going to do tomorrow, will come down over the next couple of days. And by flight day 6, we expect to have the full story put together, all the interpretation done, and a complete knowledge of the status of the orbiter.
Stay right in front, right there, Bob.
Bob Woodard from ABC News. The heaters that you added to the shuttle, did you get a sense that they worked? You know, you mentioned that the ice ball was smaller, for example. Did that have anything to do with the heaters at all? I guess not. So did the heaters work? Did you get a sense of how they worked? Did they accomplish what you'd hoped to accomplish?
Well, the one ice ball that we did see form, as Mike described to you, was not in an area where we put the heater. It was really very far down on the tank in an area where we had determined that ice, small amounts of ice in any event, were not of any consequence to us because it was just too far toward the back end of the vehicle to cause a problem. So the heaters that we put on the bipod were absolutely mandatory. I have no doubt that those heaters having a function, those metal fittings bolted to that cryogenic tank would have been covered with ice. So they absolutely did their job. The heater we put in the LOX feedline bellows, it's hard to say whether it would have been required today. With the heavy condensation that we saw coming down, that tends to keep ice from forming. In any event, that heater was on, we saw no ice, and that was the objective, whether it was the heater did it or whether it was the condensation that kept ice from forming in that area.
All right, we have time for 2 more questions, and that is it. Let's stay right along there on the wall.
Stephen Young with spaceflightnow.com. I wonder if I could just follow up on Mike's question at the beginning of the news conference. Those of us who watched the ET-CAM footage saw what appeared to be a fairly noticeable piece come off. I was just wondering if any of you did see that, whether the camera angles make it look larger, or, you know, I just worry that we might blow this out of proportion before you get a chance to address it after the proper analysis has been done.
Didn't see it. Haven't had a chance to see that one. You know, if you give these guys a chance to take a look at this film and photography, we'll get back with you and tell you exactly what it was. I mean, if there was something there, these guys will find it. So just give us a chance to go take a look. And
I'd say it was up to you guys not to blow it out of proportion.
Right.
I was going to say the same thing.
I don't have that knob. So
wish I'd have thought of that.
Our guys are going to take a real serious look at the end-to-end footage. In fact, a danger would be possibly seeing something that's very large and visible that we haven't had a chance to look at, and ignore something that would be smaller and more significant. The guys are going to take a professional look at every frame of footage that we have from every camera that we have, because as I've said and others have said several times, these are test flights right now. The primary object under test is the external tank and all of the design changes we made, NASA made, to that tank so that we would never have a repeat of 107.
All right, final question. Let's stay at the very back. Would you please walk over to the microphone?
Dave McDaniel from West 2 News in Orlando. I know that you went to some detail about explaining that you want to see all this footage and stuff, but the thought that this large piece of debris comes up has to give you some pause and some uneasiness at this point.
Well, let me just say, there are things that we know that come off the vehicle. The paper covers on the RCS thrusters. Some of those come off early, some of them come off late. The photo experts have trained and are practiced in looking at these things to tell whether you're looking at a big thing that's a long way away or a small thing that's close to the camera. I personally have not really looked at the footage. I mean, we kind of halfway watched during the launch, one eye out the window, one eye on the TV screens. So I didn't see it. But the folks that are going through this review are going to look at it very carefully. And if there is something there, we will get back with you. I've got to tell you, too, that we're going to do a very thorough inspection of the orbiter thermal protection system in the next 2 days. First with the boom sensor system tomorrow, and then with the rotation pitch maneuver and the pictures from the International Space Station on the following day. So we are going to know, without a doubt, the status of the thermal protection system before the Discovery crew comes home. And whether there are questions, of course, we haven't had a chance to look at all the film today, so no telling, what might be there or what's not there. We hope nothing.
That'll be the final word. Thank you, ladies and gentlemen, for covering today's launch. For continuing coverage of the mission and for continued briefing, please tune into NASA TV and nasa.gov. Thank you very much, and have a nice afternoon.
This is Mission Control Houston. Discovery is currently 139 statute miles above Spain. As on board, the crew has been given a go for orbit operations. The payload bay doors were opened. The radiators along the interior of the doors activated before that. All of that going very smoothly. The go for orbit operations was passed along to the crew about 11:19 a.m. Central Time, just about 15 minutes ago or so. That was just after the completion of the opening of the payload bay doors performed by the crew. We did receive television of opening of the payload bay doors, that via a electronics systems test laboratory here at the Johnson Space Center. It just so happened that Discovery was passing within range of the tracking communications network at JSC during the time of the opening of the payload bay doors. This is a playback of that view that was seen live, again through a communications station here at the Johnson Space Center as the payload bay doors were opened aboard Discovery. That operation going very smoothly. Shortly after that, the crew given a go for orbit operations, which is a formal go to plan for an extended stay in orbit. At the time of door opening, Discovery was above northern Mexico and then Texas and then across the United States northeast before crossing off the Atlantic coast.
Houston, Discovery, blocks 11 and 12 are complete. Block 14 in work.
Copy all, thanks.
Again, this was video received down via a communications and tracking site at the Johnson Space Center of payload bay door opening aboard Discovery. That occurring about 11:19 a.m. Central Time, all going very smoothly. Discovery in excellent health according to data and mission control as the crew continues on with setting up shop and preparing for their first night in orbit. Major activities coming up for the crew include a checkout of the robotic arm on board Discovery, where the arm will be powered up and uncradled briefly to ensure it's working well for the operations it'll be used for in the coming days. That is planned to take place about 12:44 p.m. Central Time. As the arm is powered up and unberthed, also cameras on it will be used to take a look at the KU band antenna and the boom that will be used for inspections of the wing leading edges and thermal protection system of Discovery later during the flight. Although that imagery won't be sent to the ground, that'll be the imagery of the KU band antenna and the boom is being taken just to ensure there's adequate clearance, as has been the case pre-flight. It'll be sent to the ground on flight day 3 for analysis by engineers. The KU band antenna, the antenna that enables much of the television from Discovery during its flight, will not be deployed until about 3 a.m. Central Time on Wednesday. The imaging of the KU band antenna and boom clearance will be seen live by the crew. They can gauge to ensure that operations to deploy the antenna are not a problem. The crew begins their sleep period this afternoon about 3:39 p.m. Central Time. Just before that, at about 3 p.m., they'll also fire Discovery's orbital maneuvering system engines again. To adjust the rate at which Discovery is closing in on the International Space Station, raising Discovery's orbit slightly. This is a live tracking map from the front of the International Space Station flight control room. The station crew, which watched the launch of Discovery live via a special uplink from mission control of television and audio, will be going to sleep about 4:30 p.m. Central Time this afternoon. They'll begin some sleep shifting to match the crew of Discovery's wake-sleep cycles tomorrow. The station just about to move into sunrise as it crosses the southern Pacific. Discovery in this view above northern Africa. Discovery closing in on the station. Again, the rate at which Discovery closes in on the station will be slowed about 3 p.m. when Discovery's altitude is raised, its orbit moved higher, that having the net effect of slowing the rate at which Discovery is closing in on the station. That'll be the first in a series of engine firings that will culminate in the docking of Discovery to the International Space Station, which remains planned at about 6:18 a.m. Central Time on Thursday.
Houston Discovery, we'd like to put APU steam vent heater activation and config for burn control and work.
and Vegas, Houston, you are go for both. As Discovery approaches its second sunset of the past 2 hours that it's been in orbit, here in Mission Control, flight control teams are beginning a handover. The Ascent Entry Flight Control Team that's been on duty for launch under the direction of Ascent Entry Flight Director Leroy Kane is in the midst of a handover to the Orbit 2 or Second Shift Flight Director, Tony Soichi, who will man that shift throughout the duration of Discovery's flight.
Houston Discovery, we're going to put config controls for on-orbit, pages 1-17 through 1-26 in work.
Copy, we're watching. Handling communications at present with Discovery and during the launch was spacecraft communicator Capcom astronaut Ken Ham. Providing communications for the oncoming flight control shift will be astronaut spacecraft communicator Capcom Julie Payette. The plans for the remainder of the cruise day today are little changed from what they have been pre-flight with Discovery in good health. No systems problems of concern being worked in Mission Control at this time. Among activities coming up will be a checkout of the Shuttle robotic arm. That will begin about 12:44 p.m. Central Time by the crew. Working with that, astronauts Andy Thomas and Charlie Camarda. We do anticipate on NASA television at about 1 p.m. Central Time a replay of video taken in mission control during the launch of Discovery to orbit this morning. That replay from a handheld camera that was used in mission control during launch. That replay again anticipated around 1 p.m. Central Time on NASA television. To recap, the crew aboard Discovery opened the payload bay doors just about 11:19 a.m. Central Time. Shortly after that, going very smoothly, Flight Director Leroy Kane gave the crew a go for orbit operations. That the point at which the crew is given a go for an extended stay in orbit to plan and continue preparations on board for mission operations. Discovery is currently in an orbit with a high point of 142 statute miles, a low point of about 98 statute miles. That low point of Discovery's current orbit, 98 statute miles, is among the lowest altitudes ever flown by a space shuttle. It's being done for a couple of hours to assist in the rate at which Discovery is catching up with the International Space Station. It's as planned for the standard rendezvous to be flown by Discovery. Discovery will raise its orbit again with an engine firing planned just before 3 p.m. Central Time, to slow the rate at which Discovery is closing in on the International Space Station. The upcoming engine firing by Discovery, again about 3 p.m. Central Time, will raise that orbital low point to about 141 statute miles, and the high point of Discovery's orbit at 191 statute miles. Discovery will remain in that orbit throughout the duration of the crew's sleep period. The International Space Station is at an altitude of around 225 statute miles. Throughout the next day and a half, as Discovery rendezvous with the station, its orbit will be increased. The shuttle's orbit will be increased until it matches that of the station during the final phase of rendezvous early Thursday morning.
Discovery. The config controls for on-orbit is complete on the flight deck. We'll work on the mid-deck. We're ready for hydraulic thermal conditioning when you are.
And Vegas, you have a go for high thermal conditioning. This is Mission Control Houston. This is a live television view from cameras on the International Space Station. The station at an altitude of 225 statute miles approximately. The destination for Discovery now, as over the next 2 days, Discovery will slowly close in on the complex, planned to dock with the station at about 6:18 a.m. Central Time on Thursday. This a live view again of television from the International Space Station, a camera mounted on the exterior of the complex. Directly in front in this view is the Quest airlock, the U.S. Quest airlock of the station. This camera is mounted on the exterior of the station's Destiny laboratory. Again, this is a live television view from the International Space Station. Station just crossing over Baja, California. Station's course will take it across the central United States and above the Great Lakes area before it moves above Canada and then off the Atlantic coast of North America. On board, Station Commander Sergei Krikalev and Flight Engineer John Phillips are in the latter part of their day. They'll begin their sleep period at about 4:30 p.m. Central Time. The crew on board the station did watch Discovery's launch via a special television uplink done by Mission Control in Houston. They watched it live as Discovery climbed to orbit. As the station crosses above the United States, Discovery at this point is on the nighttime side of Earth above the southern Indian Ocean. Discovery is also at a much lower altitude than the station. The station at a roughly circular orbit of about 225 miles altitude. Discovery currently in an orbit with a high point of 142 miles and a low point of 96 miles, closing in on the station with each orbit of Earth.
Houston Discovery for config for controls for the mid-deck, page 125 in post-insertion.
Go ahead, Wendy, I'm with you.
Yeah, I'm checking MA-73 Charlie, row echo, AC-2 payload, 3 phases still out. You want me to push it in?
Stand by, Wendy. I'll get right back to you.
Copy.
As we watch live television from the International Space Station as it crosses the central United States. We're listening to audio from Discovery and Mission Control as Discovery's crew works toward the next activity for them, a checkout of the Shuttle's robotic arm, that planned to begin about 12:44 p.m. Central Time. That just to power up the arm, uncradle it, and ensure it is in good working order, ready for its use in the days ahead. In Mission Control, handover continues of responsibilities in the control center between teams, the ascent entry team.
For Wendy, you have a go to push that circuit breaker in.
Okay, when I complete that, then our mid-deck pages 124, 125 are complete.
Okay, great, thanks.
In Mission Control, handover continues between the ascent entry flight control team, handing over to the Orbit 2 or second shift flight control team for Discovery's flight. Progressing, all systems in good shape for Discovery. The plans for the rest of the day for the crew, little change from what they have been prior to Discovery's launch. The standard plan with the crew again checking out the robotic arm, headed toward a sleep period that will begin for them at about 3:39 p.m. Central Time this afternoon. Before they begin their sleep period, also at about just before 3 p.m., another engine firing by Discovery, that to adjust the rate at which it's closing in on the station, raising Discovery's current orbit, with the net effect then of slowing down the rate at which Discovery closes in on the station. One note about Discovery's current orbit, its low point of the current orbit is an altitude of 96 statute miles. That among the lowest altitudes a space shuttle has ever flown in orbit. Done to allow Discovery to catch up on the station as part of its standard rendezvous plan with the complex.
Discovery with an update.
And go ahead, Eileen.
Well, we still have a few more things in post-insertion to complete. I'll read those down to you. The quick-on mask setup is in work right now. The OCAC will do per the flight plan. This is on page 1-7. The specialist seat removal and stowage is almost complete. On page 1-9, airlock setup for ingress. We'll call that later, and reset caution and warning. Otherwise, the activities in the post-insertion checklist are complete. I'm going to move, some of us will move on to the flight plan, and we're going to start with the easy activities lamp test.
Okay,
Eileen, we copy. You have quick down masks, OCAC later, specialist seat removal and work, and the airlock setup for ingress and resetting caution and warning are going to come later as well. We also have the flight plan open, and you have a go for the lamp test in the easy activities block.
Roger that, and Steve wanted me to let you know that PGSC setup is in work.
Okay, great, thanks.
Houston, Discovery. Lab test is complete and good. OIU activation is in work. Step 3 only.
Copy, we understand. And while I got you, Eileen, from the launch team down here, we have a lot of smiling, happy faces now that the United States is back in the crew launch business. There's some thrilled folks all the way around the world on the launch team, and we appreciate all the work you've done. Tony and Julie are ready to take over and bring you through the Orbit 2 shift.
Well, those are some great words to hear, Ken. We know that the folks back on the planet Earth are just feeling great right now, and our thanks to everybody for all the super work that's been done over the past 2.5 years to get us flying again. And I do want to pass on, from those of us who have flown before, that was by far the smoothest ascent through first stage and up to MECO that we've ever experienced. And the great weather and everything put together, nice ascent with no malfunctions, couldn't ask for a better flight. So thanks to everybody down there on the ascent team, and we're looking forward to seeing you in 12 or 13 days for the entry and landing.
And you got it, Eileen. We'll bring you home safe then.
Houston, Discovery for PDRS, standing by for on-orbit initialization, page 1-2, when you're ready.
Discovery Houston, this is Julie and Tony Sicacci and all of Orbit 2. Absolutely delighted and honored to be talking to you for real, and we're ready for step.
Thanks, Julie, and work.
Discovery Houston for CCTV.
Julie, bonjour from Orbit. It's Steve. Go ahead.
Steve, bonjour. How you doing? Hey, we have a heads up for you. In 15 minutes from now, at 0301, we'll have Dryden video available. And if you wish, you can set up a camera in the flight deck, and we can downlink it. So it's at 0301.
0301, and Soichi is in work on that right now. And to answer your question, we are all doing absolutely fantastic. It is just beautiful to be up here with Discovery, and thank you all.
Well, thanks to you, and this is going to be very exciting 13 days, and we'll be following you, Steve, on your network configuration. Keep us to date.
Yes, indeed. That's in work right now on the flight deck. Doug, WLES, and LCS.
Copy that.
Houston, Discovery is ready for APCU-1 activation. It's your call.
Discovery, Houston, Eileen, we'll go for APCU-1 activation.
It works. Houston, Discovery ready for step 7 in the RMS on-orbit init procedure. Port MPM deploy, followed by starboard MPM deploy if you're happy.
Discovery, Houston, Vegas, if you don't mind, would like only step 7 port MDM deploy only, and we'll do the starboard MDM after the checkout is complete.
Copy that. I forgot about that, Julie. Thanks. That was a good reminder. And I'll put step 7 only in work.
Copy.
This is Mission Control Houston on board the Space Shuttle Discovery. Steve Robinson reporting that he is partially through the initiation procedures for the shuttle's robotic arm, known as Canadarm. The Payload Deployment Retrieval Systems officer here reminding him that he only needs to power up one string of the robot arm connections at this point, as the robot arm will be put through its first paces of the mission as it gets a checkout, and in the process of doing that checkout, takes a look at the clearances between the new orbital boom sensor system and the KU band antenna, both of which are on the starboard sill of the payload bay. The arm itself is on the port side of the payload bay. Here in Mission Control, the team of flight controllers has completed its handover. Leroy Team's ascent flight control team having handed over the control of shuttle operations to the Orbit 2 team of flight controllers led by Flight Director Tony Sakachi.
Houston, Discovery, on orbit and it's complete, ready for RMS power up if you are.
Discovery, Vegas, we are ready for power up.
And Jim Kelly on board Shuttle Discovery reporting that power up of the robotic arm is ready to begin.
Discovery, Houston, for timeline.
Houston, we're ready to take that call, but before that, we understand the downlink is just after 3 hours MET. Apparently, we have an AVIU that's not malfunctioning or a cable. So right now, we're trying to swap out the AVIU or a cable. So we may not have that in time, just to let you know. And go ahead on the timeline.
Copy that, Eileen, and this is at your convenience, so that's no problem. And let us know how your troubleshooting goes. For timeline, 2 notes. The first one is on the water spray boiler DTO. It seems that we will reach our optimum temperature for the DTO a little earlier than planned. So if you don't mind, we'd like to move up the start of the DTO at 0315-315 instead of 3:30. And the second note is regarding the first on-orbit burn. You can expect it on time as per the timeline.
Water spray boiler DTO is 0315, and the burn will be on time per the timeline.
Okay, good copy.
Space Shuttle Discovery currently orbiting at an altitude of just under 70 miles, statute miles, with an elliptical orbit of, with a high point of 138 statute miles. We're expecting to receive some downlink video from on board the Space Shuttle Discovery as we pass over the Dryden Flight Research Center, where there's an antenna capable of receiving the high-speed television signals. As that video becomes available, we'll be putting it out on NASA television.
Discovery Houston for camera config.
Go ahead.
Hey Vegas, we have good setup here down for the Dryden video downlink. However, we think that one of the cable culprit for problems with the AVIU is often the cable that goes from the AVIU to the camcorder. That one tends to get loose. Maybe you want to check that one particularly.
Soichi check-in and break. If you're ready, I'm going to put step 5 of RMS power up, port MRO release, and work.
Vegas, we're ready for step 5.
Meanwhile, Jim Kelly on board the Shuttle Discovery, getting ready to activate the Space Shuttle's robotic arm, perform its initial checkout for this 12-day mission. It will be brought to task many times during the flight. Its first job will be to check out the clearances between the new orbital boom sensor system and the KU-band antenna, which are in the forward starboard section of the shuttle's payload bay. We have a computerized graphic that's driven by real-time data on board the Space Shuttle that can show you a look at the payload bay and its configuration, In the lower left-hand portion of your picture, you can see the very front corner of the payload bay on the right side.
Discovery. Hello, Soichi. Hello, everybody. We have good flight deck video from Discovery in space. We have 3 minutes of KU. Hi, Steve. Eileen, how do you do? And Steve, if you can make a sign with your hand, which AVI unit was it?
We can actually hold it up and show it to you. It looks like it was the AVIU. And good. Which? It was the one in the still in the go box. And you can thank Soichi for his quick work there.
Thank you, Soichi. Arigato.
Currently receiving live downlink television from the aft flight deck of the Space Shuttle Discovery. Commander Eileen Collins reporting that the crew is doing well on orbit, and that Soichi Noguchi, the Japanese astronaut, was the first to locate a problem with one of the cables that was preventing them from sending down this video. Again, the video coming down to us briefly as we have contact with the ground station at the Dryden Flight Research Center in California. Steve Robinson on your left. Jim Kelly, known as Vegas, in the center of your screen. Kelly continuing with his preparations to activate the shuttle's robotic arm and put it through the initial checkout procedures, and also take a close look at clearances between the newly installed orbiter boom sensor system and the KU band antenna system on the same side of the payload bay sill. Commander Eileen Collins in the lower right-hand portion of your screen.
Discovery Houston, question on the AVIU.
Go ahead, Houston.
Eileen, if you don't mind reading us down the serial number for that unit, and if you can tell us also if you think it was a power or a video problem with it.
Okay, stand by.
Houston Discovery for the AVIU.
Go ahead, Soichi.
Hey, Joey, this AVIU serial number is 1024.
Copy 1024.
And Joey, actually I swapped both the cable and AVIU, so I don't troubleshoot far enough if it's AVIU or cable. Just swap to the new cable in A16 as well.
Hey, thanks, Soichi. We copy. You swap both the unit and the cable. Thanks.
And Julie, one question. He was in A17 camcorder back number 2. I picked up the cable and the AVIU.
Copy A17.
This is Mission Control Houston. We have lost our television signal through the Dryden Flight Research Center as Discovery heads out over the midsection of the United States and the Great Lakes at an altitude currently of about 70 statute miles.
And Houston Discovery, we completed block 16 from post-insertion. That's the caution and warning reset.
Copy, Eileen. Block 16 complete.
And we'll call down, as we complete the post-insertion, we'll be calling that down to you. I had let the asset team know about the blocks that we still needed to complete, so I'll call those down over the next couple hours.
Copy that, Eileen, and they've passed that along with us, so we're going to just wait for your call. Discovery Houston. Information, unfortunately we've lost the video where LOS with Dryden, but that was really great to see you. Thanks for doing that, and thanks for the great troubleshooting work.
All that great training.
Discovery Houston for Eileen, if you have a second.
Go ahead.
Hey Eileen, we have good start data here on the ground, so if you have a second, we'd like you to perform the IMU Star of Opportunity align at this time. That's
Houston Discovery, contact.
Discovery Houston, Eileen, there was a handover. If you're ready to copy, we have good star data on the ground, and we'd like you to perform the Star of Opportunity align at this time, if you can. That's on page 7-6 in the Orbital checklist, and we're looking for star 57 and 84, and you can then align all three IMUs.
Houston, we see star 57 and 84 in the table. We'll go to page 7-6 and align all three IMUs. And understand you want that before the DTO.
And you're absolutely right. We didn't want to lose the stars before we go to OPSATE and the DTO, so that will clear matter.
Houston Discovery, we copy that. We'll put that in work in order. RMS power-up is complete with no problems.
Vegas, we copy and concur. Good job. Discovery Houston, you are go for the item 16 when you get there.
It's in work.
This is Mission Control Houston, spacecraft communicator Julie Payette of the Canadian Space Agency, reporting to the crew on board Discovery that they're in a good configuration to align the inertial measurement units on board the Space Shuttle Discovery. This is a regular activity done to make sure that the navigation systems have all the latest data. It's done through star trackers mounted in the nose of the orbiter that point toward known stars and are able to produce very detailed navigation information for the computers on board the Shuttle Discovery.
We're going to clean up from that and move on to water spray boiling cooling verification. And by the way, the visual inspection of the vent port in the aft by the tail is completely clean.
Hey, Vegas, we concur with your plan, and great news on the vent port aft.
Jim Kelly reporting that the crew on board is ready to do what's known as a detailed test objective. This is one that's looking at the water spray boilers that are associated with the auxiliary power units on board the Space Shuttle. These water spray boilers, after spraying water, freeze each time that the APUs, as are known, are shut down and tend to remain frozen for an unpredictable length of time. One possible solution is to replace water as a cooling fluid in that water spray boiler tank with a mixture of 53% water and 47% propylene glycol monomethyl ether, known by the acronym of PGME. Some tests done at the White Sands Test Facility in New Mexico show that combination isn't as likely to freeze, and the conditions are seen on orbit. For this test objective, the Shuttle Discovery had one water spray boiler, number 3, filled with this antifreeze mixture. And they're going to conduct this test now. The primary objective is to confirm those ground test results that were seen at the White Sands Test Facility, making sure that the liquid performs the same on orbit post-launch in the high vacuum zero-G environment. They also hope to look at what kind of coolant usage is found when this system is used. Jim Kelly, the pilot on the mission, is scheduled to execute the detailed test objective.
Discovery. We're in the G2 to G8 transition, page 4-6. We'll go in free drift and then the ops 801.
Copy Discovery, Eileen. We're following along.
Again, pilot Jim Kelly working with a water spray boiler test objective that's looking at replacing pure water with liquid that's half antifreeze, known as propylene glycol monomethyl ether, to try and fight a tendency for the water spray boilers to freeze up when they're done. Auxiliary power units are those power units that generate power for use in the dynamic phases of flight, such as launch, ascent, and entry. They're used to control the mechanical steerage devices on the shuttle. Right now, Discovery is orbiting at an altitude of about 70 statute miles above the surface of the planet, just off the western coast of Portugal, making a southeasterly track toward the northwestern coast of Africa and the Sahara Desert. Discovery currently about 10,600 nautical miles from the International Space Station, its intended destination, closing at a rate of about 850 nautical miles per orbit. That converts to about 12,200 statute miles away from the space station, closing at about 980 statute miles per orbit. Our next rendezvous maneuver in this gradual game of catch-up with the space station, scheduled to commence in about an hour and 37 minutes, and that will slow down the rate of approach. Flight dynamics and trajectory officers here in Mission Control currently in the process of computing exactly how long that burn will be and how it will change the shuttle's orbit. On your NASA TV schedule, you'll see that about this time we are expecting to have some replays of the Ascent Flight Control team in action during today's launch and ascent into orbit. Currently, we are working on getting that replay ready for you.
DTL, and we are ready for APU 3 start, step 4.
Vegas, your go. APU start, step 4.
And work.
Discovery Houston for PDRS.
Go ahead.
Hey, Vegas, when your robotics crew is ready, we are ready on the ground to proceed with RMS checkout.
Camarda, we'll give you a call on that. We're cleaning some stuff up, and then we'll put it in work in a little bit. We'll give you a call.
Sounds great.
Pilot Jim Kelly reporting that he's doing a little bit of cleanup on board the Space Shuttle Discovery as he has initiated power to the Space Shuttle's robotic arm, known as Canadarm, powering it up and getting it ready for a checkout and quick survey of the payload bay, and in particular looking at the distance between the KU band antenna system and the new orbital boom sensor system that will be brought into play tomorrow to scan the thermal protection surface of the shuttle for any possible damage that occurred during launch. Kelly also working with this detailed test objective, number 850, on the water spray boiler cooling, checking out how a new mixture of antifreeze in that cooling system for the auxiliary power units that provide power during dynamic phases of flight can help to prevent freezing of the water spray boilers that cool those units each time they're shut down. These views on NASA TV are a computerized generation driven by real-time data showing the positions of the robotic arm in Discovery's payload bay.
Discovery Houston for the water spray boiler. We are seeing good cooling on water spray boiler number 3. So you are go for step 5 APU 3 shutdown.
And work.
Spacecraft communicator Julie Payette telling Jim Kelly on board Discovery that it's time to shut down that auxiliary power unit. Again, it was being tested for the use of a new antifreeze in its water spray boilers that provide cooling for those power generating units. So the STS-114 return to flight crew of the Space Shuttle Discovery getting busy immediately after their on-time launch at 9:39 a.m. Central Time today. Commander Eileen Collins working with Kelly at this point on that water spray boiler detailed test objective, also in the midst of her pre-sleep activities.
Houston Discovery, we're going to step on to Elevon Park.
Good call, Vegas. Elevon Park required.
Kelly also one of the prime arm operators on this flight, and he's now moving the
01.
Eileen, we're ready.
As Jim Kelly and Eileen Collins wrap up this water spray boiler detailed test objective, Soichi Noguchi on board the shuttle working with television setup, while Steve Robinson is focusing on setting up the laptop computer network on the flight deck of the Space Shuttle Discovery. Andy Thomas setting up the water systems for the galley at which they will prepare food, and also working on the robotic arm checkout. Wendy Lawrence helping Noguchi with the television setups. And Charlie Camarda working with Steve Robinson on the computer setups, and also working with Andy Thomas on a checkout setup for the robotic arm. Again, we are still planning to replay video and audio of the Ascent Flight Control Team in action during today's launch that occurred on schedule at 9:39 a.m. Central. We'll have that for you in the very near future.
Yo, Vegas, we saw a good park, so you're go to put the height circ pump, number 1, back to GPC.
And we're
And Houston Discovery on the timeline.
Go ahead, Eileen.
Okay, we've got Andy and Charlie in the flight deck, and they're going to try to get started here on SRMS checkout.
Copy that, Eileen, and we're ready for that.
Okay, and they also completed block 15 of post-insertion for the airlock. And we're on page 9-6 at this time, step 7.
Eileen, we copy. Block 15 for the airlock is complete, and you're on 9-6.
Houston Discovery, would you like 184 for the puck and move format?
I guess we'll take it. Nice to hear you. This is Julie, and we're ready for PDRS.
Good evening. Nice to hear you too. And we're starting our RMS checkout, page 3-2.
Andy, we're with you.
This is Mission Control Houston. Andy Thomas on board Shuttle Discovery reporting that he and Charlie Camarda are starting the robotic arm checkout in Discovery's payload bay. They'll be operating the Canadarm from the aft flight deck workstation. This checkout occurring over the southern Pacific Ocean. Payload Deployment and Retrieval Systems Officer here in Mission Control, watching over these systems. You can see the back of her head in the lower right section of the screen here. This Orbit 2 team again being led by Flight Director Tony Soichi, with Julie Payette providing the communication back and forth between the crew on board Discovery. Andy Thomas and Charlie Camarda putting their robotic arm through some very small movements as they begin the checkout. This is a computer-generated view using real-time telemetry from the Shuttle Discovery to show the arm's position on the port side of the cargo bay. Behind it, toward the front of the cargo bay, are the airlock and the external stowage platform that will be installed on the outside of the International Space Station later in the mission.
One config, if you are.
Eileen, we're ready for PCS-1 config.
Houston, it looks like we have Radicom. PCS-1 config, I'm ready to start if you are.
Eileen, your go for PCS-1 config.
Okay, the O1 pressure is approximately 15.0. Spec 66 is 14.6.
We copy both. Thank you.
probably see it, but airlock P 14.9.
Copy, Eileen.
Majority of this robotic arm checkout will be performed at the pre-cradle position. That's where the robotic arm is just above the port sill of the cargo bay. Again, this is near the pre-cradle position where the shuttle's robotic arm is about ready to be latched back into its moorings. This is a checkout that's being conducted by Andy Thomas and Charlie Camarda, two of the mission specialists on Discovery. Again, in this computer-generated view, you can clearly see the external storage platform that will be lifted out of the Space Shuttle's payload bay and installed on the side of the International Space Station, carrying with it some orbital replacement units that will be used for future station maintenance activities. To the aft of that in the payload bay here, you can see the Raffaello multi-purpose logistics module. Crew members on board the shuttle currently conducting environmental tests, seeing how the atmosphere is inside the MPLM. And behind that large cylindrical module is the thermal protection system test bed in the back of the cargo bay that spacewalkers Steve Robinson and Soichi Noguchi will use to test two different potential thermal protection system repair techniques on the first spacewalk of the mission on flight day 5.
Discover Houston for PDRS.
Hey, go ahead, Julie.
Hey, Charlie, nice to hear your voice. Welcome to space.
Thank you. We're enjoying it.
Copy. If you don't mind, if you guys are not going to proceed right away into direct mode checkout, would you mind getting out of direct? That would certainly please our PDRS folks here.
Yeah, Julie, we just paused for a moment. We're going to pick it right up right now.
Copy, we're watching.